Lesson 4-3, Solving System of Equations by Elimination. The goal of this lesson is to be able to solve systems of linear equations using the elimination method. So vocabulary to review is coefficient. A coefficient is simply a number that is multiplied by a variable in an expression. In the example of the term 3x, the coefficient is 3. Elimination means to cancel out or eliminate a variable. Using the elimination method, our goal is going to be to eliminate either the x variable or the y. We do this by following algebraic steps in solving systems of equations by adding or subtracting the system of equations to eliminate a variable. And you're going to learn about the process of doing that. So in this mini lesson, we're going to determine whether each system of equations has an opposite coefficient. So we're going to look at the coefficients carefully of the x term and the y term and determine if they are opposite. If so, we're going to circle them to identify them. In this first example, we have negative x plus 3y is equal to 16 and x plus 6y is equal to 12. So you should notice that we have these two that are the opposite. We have a negative x and a positive x. These are opposite coefficients. If I would put a number there, it would be a -1 and a 1. So yes, this system of equations does have opposite coefficients. As we look at the second example, if I look at the coefficient for x, I have 2 and 7. Those are not opposite. As we look at the coefficients of y, I have a -5 and just 1. Those are not opposite, so no, these do not have opposite coefficients. In the third example, if we look at the x's, we have the coefficient 9 and 4. And for y, we have the coefficient 4 and -3. Neither of those are opposite coefficients, so no. This third example does not have opposite coefficients. And then the last example we have, for x, we have a 4 and a 1. For the y's, we have a -2 and a +2. These are opposite coefficients, so this would be a yes. And you're going to see how this comes into play in this lesson. In example number 1, we're going to be solving a system of equations by adding to find the solution. Remember, all solutions to systems of equations, if they have one, are represented as an ordered pair x comma y. So I'm going to go ahead and focus on this first example. So I'm going to do what we just did above. I'm looking at if there is opposite coefficients already in this system. And I notice we have these that are the opposite. We have a positive yx and a negative yx. So when we do the elimination method, we combine and add both systems. Since these are the opposite, these are going to cancel out. So I am left with x plus 2x, which is 3x. I'm going to bring down my equal symbol. 7 plus 2 is 9. By eliminating the y, that leaves us just with the x variable. So the next step is just to solve for x. So we're going to divide both sides by the coefficient 3. Therefore, x is equal to the value of 3. So that is half of the solution. Then we take this 3 and we're going to substitute it back into one of the two original equations to solve for y. So if I go with the first one, I have x plus y is equal to 7. I am going to substitute in the 3 for x. So I have 3 plus y is equal to 7. My new equation only has the variable y, so to solve for it, I have to subtract the constant 3 from both sides. 7 minus 3 is 4. So the solution to this system of equations is 3, 4. The x coordinate is equal to 3 and the y coordinate is equal to 4. So I can say, whoops, the system of equations has one solution, and that is at 3, 4, and I'm going to write it as an ordered pair. Okay, an example, or in the try it's, we're going to practice that a little bit more. We are going to solve each system of equations by elimination. So the first thing we're going to do is, looking at example 1a, we're going to look at which coefficient, if any, is already the opposite, and I'm going to identify it by circling. So we should notice that the y's are the opposite coefficient. So since those are the opposite, those get eliminated, they cancel out, and then I can add the other two terms in the system. I have 2x minus x is just x. I'm going to bring down my equal. 2 plus 3 is 5. So this one was simple. X is just equal to 5. Now I need to solve for y. I am going to substitute in this 5 for either this x here or this x here and solve for y. It doesn't matter which one we choose. I'm just going to go with the first one. So I have 2 times whatever x is minus 4y is equal to 2. You're going to notice this is very similar to the substitution method once we find one of the solutions. So my new equation only has the variable y in it, and then I just do the math. Whoops, let me change that. Should have been a 5. Two times 5 is 10. Then I'm going to bring down my minus 4y, that is equal to 2. To solve for y, I'm going to move my constant 10 by subtracting it from both sides. So we're left with negative 4y is equal to negative 8. To solve for y, we divide by our coefficient negative 4. A negative divided by a negative is positive. So here's my other half of the answer. So the solution to this system of equations as an ordered pair is 5, 2. Okay, let's look at try it 1b. So take a moment, analyze the coefficients and determine if there is a coefficient that's opposite. We should notice that for the x's, those are opposite. We have a positive 2x and a negative 2x. So if I add this system of equations, that will cancel out. A 3y plus a 2y is a 5y. A 1 plus a negative 6 is a negative 5. If I continue and solve for y, I divide both sides by 5. A negative 5 divided by a 5 is a negative 1. Then I can take that y value and I can substitute it into the first equation for y or the second equation for y. Either one will work fine. I would encourage you to try both just to confirm. So if I go with the first equation up above, I have 2x plus 3 times whatever y is equal to a 1. We just determined that y is equal to a negative 1. So then from here, you should notice that your equation only has the x variable and you're going to solve for x. So we have 2x minus 3 is equal to 1. Add 3 to both sides. So we have 2x is equal to 4. And lastly, to solve for x, we divide both sides by the coefficient 2. Therefore, x is equal to 2. So the solution to this equation as an ordered pair, the x-coordinate is 2 and the y-coordinate is -1.